everybody, it's Tyler here at the Pikes Peak Signature event, checking in with 99067A. This is Mechanical Jagwires coming in. Great performance so far coming into the Signature event. A couple events wins, an Excellence Award as well, and a few others as well. So congratulations on a great season so far. Let's take a look at the robot, what they have to offer. One of the things I really love, they're doing climbs two-way, and I think that's something really cool. Not just an A-tier climb, but a BC tier climb both ways. I think is really phenomenal. But a lot of great things to be talking about with this robot. Some future plans we'll be talking about. Their wings using string tensioners, and a few other things we'll be covering on this robot. Let's learn more about them coming up here on Pits and Parts.
This video on fun is brought to you by viewers like you and also in partnership with the following. The Robotics Education and Competition Foundation provides fantastic programs for students from elementary school all the way through college. These include VEX, aerial drone competition, online challenges, JROTC, girl-powered, scholarships, certifications, and so much more. To discover these exciting opportunities, visit recf.org and get connected. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/vex to learn more and apply.
Danny, let's start with this robot front and back here with your wings. You talked about you're using some tensioners and stuff, so detail more about what you're doing, and then how did you come up with using this as well too in your robot?
Alright, so pretty much the way the wings work is that when Nick, our driver, presses the button like so, a piston, air is blown under a piston, which releases the tension in the string. And with the released tension in the string, it allows this rubber band here to pull it down. And then with the pressure of another button, the air pushes the opposite side of the piston, allowing the tension to come back, bringing it straight back up. And like this is very good because before, it's kind of unique because even me, I've never seen this before, so the string allows it to be more maneuverable, so it's not so tense, not so tight, and like there's no chance of it getting stuck during a match.
What part did, what time did you end up coming up with this? Is this a new addition to your robot here, or
this
when
is actually
this come
quite
out?
A recent addition. I know me, Nick, and Jackson, we've been working on this for quite a while, and then this is more of a recent addition within the last month.
Let's keep moving on to your robot. A few other things to talk about. Let's talk about some future plans with your slapper, Annalise, and what you're planning on doing with that here. So, interesting, by the way, with the slapper, most of them I see a little bit wider contact point there. You have the smallest. So I'd love to hear more about that, and then what you're planning on doing for future plans on that too.
I believe we kept it small so that we don't have to guess where we're going to put the tri-ball. And for future plans, we want to put a color sensor right here so that it's going to be like naturally drawn back.
So it's going to detect when a tri-ball goes in there and kind of do that auto deployment?
Yeah.
Very cool. So let's showcase how your current slapper works right now, then we'll kind of imagine what that would be like with the color sensor too.
And our reasoning for adding the color sensor is that right now with current practices, with match loading, it's hard for those match loading to be able to completely time it correctly. So when we do have the color sensor, it'll be able to just make it so that they do it at their speed instead of just trying to randomly time it for when's convenient.
One thing I want to ask you is I think about some other signature events I've been to, and the meta of this game has kind of been evolving a bit more to move away from catapults and slappers and more to just like bowling. Would you find that being more as an advantage just for skills, or is that part of your strategy for matches too?
This is more for skills because of a topic that's going to be discussed later. We are only going to be doing this for skills versus matches.
There you go. Let's keep moving on to robot. More to talk about this. You got a PTO on your robot next, so talking about how you're utilizing that PTO on your bot. And I think we were talking about earlier, you're only utilizing, I think, 2 motors out of your entire drive base for that too. I'd love to hear more about that.
Yeah. So on our robot, we have a PTO system. We wanted to add this because we wanted to do many different mechanisms, and we also wanted those mechanisms, like the climb, for instance, to have enough power. So we needed 2 motors in order to climb. And we also wanted a 6-motor drive because having the pushing power of a 6-motor drive is really good. So what we decided to go with was a PTO. Instead of shutting off the drive and putting all the power into the climb, we just did 2 motors.
Sure.
Because we didn't think we needed the full power of 6 motors, so we just went with 2, and we still wanted the maneuverability while being able to control the climb at the same time. So how it works is the piston slides this gear over. So it either powers the climb gear, which is the one that's moving, or it powers a series of 12-tooth gears that lead to the drivetrain.
I like that you're still having plenty of drivetrain power to still do your lineup and stuff like that too. I think that's great from a overall thought process and strategy-wise to go through that. So well done so far. Any big changes that you've had like recently utilizing your PTO, or is that something you've had for a long time?
We did a PTO at the beginning of the year. It was a different style, but seeing as how like we wanted everything to be in the back so that way it's more compact, so that way we can leave this entire area up here open for the pole. We wanted to make it as compact as possible, so it was a bit of a challenge to try to figure out how we can make it as compact.
That's a really good point, because when you think about packaging on the robot, we'll be working our way into your climber that you have, but I'm so glad to hear that you have that thought process in regards to how you design your robot and the packaging of that too. I think that's great for that as well. Let's keep moving on. Jackson's going to talk about, I noticed you do have a ratchet on here, so as we start to work into that climber area, talking about your ratcheting system and what you're doing.
Yeah, so we have these two metal pieces right here that when this piston disengages, a rubber band pulls them into these two gears, which prevents the climb mechanism from being able to pull up. So at the end of a match, once our robot has been disengaged, we can't use our motors to keep ourselves up. So this prevents us from falling down and losing our climb. And then we can just disengage it and we can just move as much as we want. So we have this string that pulls up the zip ties that are connected to the metal. Then, so it overpowers the tension from the rubber band when it's activated, which allows us to be able to move it up during a match and also get us in position for our second method of climbing, which allows us to get on the vertical pole, which is very helpful in matches.
You got a lot of string on your robot, by the way.
Yes, there's quite a bit of string.
Tatum, let's talk about those climbs that you have. I'm so excited to hear about this, because we've seen teams with double climbs. I don't think I've seen one that's able to do above an A tier, especially on their side climb and having a double climb. So talking about how you came up with this, and we got to demonstrate how this works too.
Okay, so this is our climb. It goes this way, and there's two ways to do the climb. There is a vertical and a horizontal climb. The horizontal climb it goes down and it lifts the bot up onto the bar, getting us to B tier. We are going to do some tuning to get us up to C tier later. And there's also the vertical climb, which goes into this little chamber spot, and it flips the bot almost upside down and holds it at around B to C tier.
I love it. I mean, overall, I think the thought process, when was this implemented in your robot? Is this a new addition for the signature event, or something that you had prior?
It's a new addition that we've added.
Well, I can't wait to see how it performs here on the field. Mechanical Jagwires looking absolutely phenomenal, so we wish you the best of luck here at this signature event. Hopefully qualifying for Worlds as well, too. I know you got big hopes for that, but good luck the rest of the way. Thanks for telling us more about your team.
This video on fun is brought to you by viewers like you and also in partnership with the following. The Robotics Education and Competition Foundation provides fantastic programs for students from elementary school all the way through college. These include VEX, aerial drone competition, online challenges, JROTC, girl-powered, scholarships, certifications, and so much more. To discover these exciting opportunities, visit recf.org and get connected. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs, where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/vex to learn more and apply. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Most live shows can be found on the First Updates Now YouTube channel, live competitions at twitch.tv/firstupdatesnow, and join our Discord at discord.gg/firstupdatesnow. Check our other social offerings on TikTok, Instagram, Facebook, and Twitter.